like, why are we discussing about minimal API or web API in Azure? What is that it has to do with Power Platform? So obviously this question would have raised to many people, and eyebrows would have raised. What in Power Platform? This minimal API? So I will set up the context. So last year we did this session in a web API. And again, I'll compare between the web API and minimal API. And in this entire exercise, if you see that, what is that we did is we created a full-fledged web API connecting to SQL Azure. And then we connected till here. That's the first piece where we created the web API. And once that web API is over, that's where we created the custom connector in Power Apps. And once this custom connector is done successfully, the next speaker, they came and did use this custom connector in their Canvas app. And another user came and they used some of the formulas to do that. So basically, whatever you're learning or whatever we are discussing today is 100% relevant to the Power Platform. So just I wanted to set the context. I just give this one URL also just to be if you guys want to dig deeper into that, what did we discussed in that session? I'm putting it here. So this web API, whatever we are developing, it's 100% relevant to the Power Platform. One of the way to use that is through custom connector, which we did it last year. Oh, 2 years ago. God. Okay, cool. So now coming back to this web API versus minimal API. OK, so if you see that web API versus minimal API. So a lot of people, they are telling that, hey, the minimal API are much faster than web API. Minimal API is much faster than web API because we are able to write everything in one single file. No, that is not. I agree because I have a um, different way to look at it. What is this minimal API and why it is different from the full-fledged API. So let me show you that minimal API structure, and then we will discuss both, why they both are different and what is the analysis which I'm bringing in onto the table. OK, so let me open the documentation first. So here is the documentation, whatever we are going to discuss. I'll put it here. This is my GitHub. So mostly I will be discussing on all the technologies, Docker, Kubernetes, Azure, microservices. So you guys can get all those things over here. I'm giving you this my GitHub link also. And whatever we are discussing in today's session itself is microservice related. So this can again be used in different client applications or in the Canvas app. So what is that? Disclaimer, I'm still a learner, even though I have gray hairs all over. Still, I'm a learner and apologize if I do any mistake. So what are we going to do today? We'll quickly look at it, the SERI log and what is CORS. And this all things will be used there also when we develop the custom connector and connect it through the Canvas app. It's 100% relevant. As I was mentioning, I always keep that video reference which we were discussing. And how do we use it. I'm using it in Angular 15 and all the latest, whatever is current, latest trendy shiny technologies like minimal API, .NET 7, Angular 15. So, and little bit of Azure also, which is very important. So that's the context which I wanted to set. Now, first thing, let's discuss first things first. I will open up this. I will open up this solution and just wanted to compare and contrast, like why is this faster? What is that which is making this faster? So let's see that. So if I come into where is that? Oh, it's not this. It's over here and inside working. Okay, I just I'll come back to this one. I think it's the fifth sample, which is full-fledged API. So web API. And how do we create? We will see that. But before that, we have to understand what is the difference between the full-fledged API and the minimal API. Okay, so first we will see at the minimal API things first, and then we'll go and compare that with the full-fledged web API so that we can get a big picture on that. So let me come back to this one. This is my minimal API. And if you see the program.cs, it's very lean. All the things has been pushed into the extension methods, but I would like to show you one simple thing. Before even we are starting the first line, this is the minimal API, and I'm executing this. When I'm executing this, we will see two scenarios. Assume that, let me show you, and then I'll explain few things. So if I do a debug over here, and if I go into services, builder.services, what is by default? The number of dependencies which are coming out of the box in minimal API is 90. So we will switch to full-fledged web API, where this is the controller. Now, same thing we are comparing with full-fledged web API. So before even we are starting the first line, if you see the number of the dependencies are same. So at the time of starting this application, just before the builder.build, if you see the number of dependencies, which is in full-fledged API is 194. And just before we add this builder.build, okay, before we start creating our app object and host it, when we compare the number of dependencies which we have, here is 112. So 112 versus 190, 190. So this is the first difference I would call. Imagine a same athlete, a person A is having 112 kgs in his backpack and is running the same speed. And the same person is having a backpack with 190 kgs. Which one will run faster? I mean, the same athlete. He will run faster when he's having 112 kgs weight. That's one thing. And the second thing is the HTTP pipeline. The second thing is HTTP pipeline. When we compare the HTTP pipeline, it is there inside this extension method. Here, the HTTP pipeline is directly you're hitting the endpoints. You're not passing it to the controllers and the heavier HTTP pipeline. Let's see that HTTP pipeline in ASP.NET Core. I always use the documentation. I don't create my own documentation because I need to copy paste. Instead, let me do this way. So if you come and see in these kind of scenarios in minimal API, all we do is we'll start the app and we'll directly expose the endpoint and we'll hit the endpoint. So it's the shorter distance to give the response out. But if you go and see this kind of middleware, I mean, we can add any number of middleware, but if you see the request is starting and it is directly coming to the endpoint and it is returning the response. We'll see that. And in full-fledged web API, it might go through some of these like authentication, authorization, or CORS, or CORS could be common in both full-fledged web API as well as the minimal API. But as and when you add more and more middleware to the HTTP pipeline, it will take extra time. Like a plain pizza, you want pineapple topping, 10, 15 rupees more. You want mango toppings, 20 rupees more, something like that. So you add another middleware. It might take few milliseconds or nanoseconds, whatever it is, but it adds up to the time. So if we see this execution, if I come into this execution, let me see what is the controller. Oh, it's a weather forecast controller. We'll see that here in the output, how the pipeline is getting processed. That's very important for us. Let's see. Is this? Yeah, this is the one. So let's assume I'm going to this weather forecast and try it out and execute. So we got something. So now wait 1 minute. I think I need to bring this configuration information, this log, so that we'll be able to see the difference. This log object. Let me bring in here and add it to the development also. So let's rerun this again real quick. Once we rerun this, we have our window here. So it's by this time it is started spitting more information, and I go and kick this endpoint and I executed it. Now, when you come here, you can see what is that it is happening. So we hit the endpoint. It received this endpoint. Then it goes to the routing middleware. And then from there, it found the match. And then it executed a method on a controller and it responded back. And it said action invoker. And it took 35 milliseconds. So it's going a little bit through the different middlewares or the HTTP pipeline. We'll see the web API, minimal API, I'm sorry. The previous one was web API, full-fledged web API with controllers. Now we are seeing at the minimal API. So this is, I mean, it doesn't matter which endpoint we are hitting, but how much we are processing is very, very important on that. So we are seeing from that perspective. So if you see, how does it start the process? So the request has started and it's executing the endpoint. OK, see this, before that, there are no logs. And here is that it started the request and it found the endpoint. it directly executes the endpoint and spits the content out. So it's not going through any of this extra middleware. But when we compare this with here, if you compare that, so you got a call here, then it is going through one middleware, and then it has to pass the controller to the controller action, which it executes and spits the response out. I mean, adding cars here, the cars is there and authentication, authorization, whatever you add it, that gets added up to the response time. So this is my analysis. Like, why is that minimal API a bit faster than web API? Because as we have seen two things, the number of dependencies which you load, each dependency is a weight, isn't it? You need to hold it in memory. So the number of dependencies in minimal API is lesser when we compare that to web API. The number of dependencies 112 versus 119. And also the HTTP pipeline, that is the middleware. Every middleware we have to cross, we need to spend some time. You add more number of middlewares, you'll spend extra time. Like if you see that here, the middleware, there are now more number of middlewares, but here the middlewares are less. So definitely this will be much faster than this, isn't it? You don't need to spend time on this action filters or exception filters or whatever it is. Rest is remaining same. So similarly, when we see it has to come through the uh, middleware, the routing middleware is the one which it was hitting. We saw that. Where was that? Here, routing middleware. Maybe it took 1 nanosecond or 2 nanoseconds, whatever it is. Then it comes to the controller, gives the control to the controller. But whereas when we see the minimal API, it directly executes an endpoint. Before that, there's nothing. Like here you have a routing and middleware. Here directly it goes and hits this endpoint. So from here, I'm jumping in and I'm going here. So in Web API, it comes to routing. It need to identify, send this to the respective controller action. It gets executed. So this is what is my independent analysis. Now, when we were speaking about the how this is applicable to our platform, is one of the way to use that is through the custom connector. So God, these guys are killing me with these advertisements. Everybody is threatening. Okay, so if you see that you can do this with full-fledged controller web API, or you can do with minimal API. Basically, it is one of the connector, the custom connector. You develop this one. So which one to choose, you guys can decide whether you need different controllers, heavier processing and all those things. You can go ahead with controller web API, or you need a lean, which is pretty fast. You can go ahead with the minimal API. And why do we need to create the custom connector at the first place? So imagine you are developing a Canvas app and the form is coming from the default store, whatever you're using as part of the Canvas app. And one particular information, let's assume that employees' personal address or employees' family members. Let's assume that one particular table or two particular tables are in a separate data store. Maybe it's in Mongo database, or maybe it's in Postgres or MySQL or SQL Server or Cosmos DB. Anywhere, there are one or two tables which is there in a separate database. So what you can do is quickly you can create the API maybe web API, full-fledged web API or minimal API, talk to the data store, expose it, and you people can create the custom connector and use it in Canvas app. Rest of the content inside the Canvas app, everything is coming from the data store which you created, but one particular thing is coming from the custom connector. So that's the motivation. Why should we learn about web API? And now the next point. So we discussed about the web API, full-fledged web API with controllers, and then we discussed about the minimal API. We compared the number of dependencies which those different APIs are loading, and the the request response pipeline it has to go through. Just give me 1 minute. And coming back to Serilog, there are different mechanisms to log, and we are using Serilog. That's best thing we are doing at this point of time. So why do you need to maintain log? You can use application performance monitoring. You have application insights and Azure monitoring, a lot of things you will have it. So you can go and use it. But why do we need to store? For multiple reasons. I'll tell you. One of the reason is if you see, it could be a mandate, like what is the user journey, and you want to store it for n number of days so that you guys can track it for mandatory reasons, or from the procedure perspective, you want the logs to be stored for a number of days. So for whatever the reason you have to store, you can store this one. And we are doing a rolling on the date. The last time when I executed was March 13. That was the demo I gave previously. And 28th April, I'm giving this demo. So if we come into this one, you will see that what was the user journey, who was going, at least which URLs has been hit, and what is the response code, and how much time it processed. Like we can get all this information. So sometimes what happens is the regulatory body, they want the things to be stored for 6 months or 1 year based on the type of business this application is supporting. They will ask mandatory to store those logs. If at all some of the user, he comes and say that, hey, I passed this information, I didn't get proper discount, or hypothetically, I'm telling that. Then you can go back to the logs that no, you have selected this option, because we'll write those logs. So just to defend ourselves, or just to go through the logs to find out for those mandatory reasons, we can do it. So that's the thing about the Serilog. So I've given the packages which we need to add. It's definitely not this one. I have to update it. The package is the Serilog package is this one. Serilog ASP.NET Core. It's not the Swashbuckle. It's my mistake. And how do we add it? We will add here. So we'll just clear all the providers, and we're writing the logger, and rest of the information is coming from the app settings. We are saying that write it to the file, and the logs folder and courses API. And we said that rolling interval is every day. If at all it is an application which has been heavily used by multiple users, in that case, we need to roll faster than that. because back in 2006, 7, and 8, we used to work in trading application, which used to uh, get heavy logs. So we used to roll, used to use Log4net, I assume. So we used to roll hourly, the logs will be there because the hourly log itself is very heavy. So based on the business use case, you need to check that what is the rolling interval you need to do it. And then coming back to the course in development mode. So first thing, let's go and see this. One piece is, let's execute this for a minute and see. It's just a simple Angular 15 application, not a uh, big thing, but npm start. Let me start this application. And in the meanwhile, I think I can close this window. In the meanwhile, I'll show you. And again, we'll go to, first we'll do the local integration within the box. And then we will go to the Azure side. We will create a app service and do a little bit deep dive into the app service plan and web apps, and how do we deploy, one of the ways to deploy it. And then I will look at it. So if you see the courses at this point of time, the courses are coming from that's coming from the Azure hosted website. So this is the school. When I'm going to the courses, I think because the app service which I have taken was very free tier or basic tier, so it will be in cold mode. So the first hit will take longer time. And now if you compare, uh, it took how much? It took 8 seconds. Now when we do the second hit, you can see that it is much faster. It didn't take 8 seconds, but it took less than a second to get the response back. So that's about the warm mode versus cold mode. Okay, we'll see that option. That's something called as always on. We will see that. So first thing what we will do is we will come back here and execute our school API. So when in good olden days, not good olden days, even 4 5 years ago, when you know one technology that should be good enough for a decade or 1.5 decades to survive. But nowadays, you need to know the entire software department. Okay, so we can't call ourselves as a front-end developers or a back-end developers or DevOps. Um, you see the agile, Scrum, and safe, agile, different methodologies are coming in and the faster to market. And one of the things is if you see Azure or AWS, while you're working, they will send updates. Suddenly the page will get refreshed. So previously when we used to work, it used to take 2 months for us to just prepare the requirements document. 2 months, seriously. And then project planning, MS project open, like who is going on vacation for next 3 to 6 months, and create those hierarchy. Okay, by the time uh, the web API is done, they need to create a mock, and we need to give them the output, and they will create the UI. So it was huge. But nowadays it's faster. Like you take 6 months, some other competitor is releasing the product you are expecting to release with 10 features, but your competitor is releasing with one product. People will start using it. By the time 6 months you're trying to release 10 features, you would have done 4 to 5 features, but people already started using it and they like it. So things are much faster. So that being said, we will see that these all are in-memory database and the content is coming. So this is what is very important for us. So when you see it is coming from HTTPS localhost 7026. So this is what you will use in the custom connector. Please watch the other video which I have sent it in the chat. So it will be useful for you to correlate. So now what we can do is here we can create the API. I don't do any changes while I'm in live, because something which is working, the golden rule of thumb, something which is working, do not touch it. OK, so now we see this. The content should come from the local API. I open this. I open the developer tools, and again I go back to come back to the home page and click on this. So it's taking some time, and exactly it is telling us what is the reason. It is failing. Course. It says that the URL localhost 4007 is not allowed, because what happens is the origin where the API exists. So the API exists in, did I close it? Oh, I'm sorry. That is my mistake. So if you see that the API exists in this FQDN. So if you see that the schema and localhost and the port number. So this is the one, but the request which is coming in is from a different origin, so that it will not allow. Let's see. I think that might be the reason. If not, it's good use case that we are hitting this course issue. I want we to hit this course issue. That's good. So it says that the this one, the UI is coming from HTTP localhost 4007, but whereas the API is coming from this FQDN. So the schema and the port, or the host and the port, those two are not matching. So in this case, we need to do a course. So we need to allow the course. So for that, we will have to go to this one. And we said allow all. OK, that is there. And OK, allow any other things. Let me do a simple debugger on this one. Let's add the course policy, and also in the pipeline, we will have to add it here. So let's start this for one more time and see that this line is hitting. If this line is not hitting, that means we are not enabling the course. So it is hitting. So we didn't write any specific thing on what has to be allowed. We said that allow any header, any origin, any method. So we have opened up a blanket statement that is, it has to allow everyone. So let's stop this and restart it again because I'm sure we have already enabled. 1 second, I still doubt. Okay, the port is different. I'm sorry, that is the main reason. This is the port. The port is on that day, the port was different. Today, the port is different. So let me come back here and it's not 7221. It is 7062. I just changed the port. And now if I come into this one, I'll go to school. And when I'm going to course, you can see that now it is allowing because we said that the response headers, if you see that, it said that access control allow origin asterisk. Asterisk is very dangerous, so never ever use it. This is just for the demo, and that is the reason. If you see in the code, we have added that inside the development environment. That means this code will not get executed when we push it to the app service, right? So this code gets executed only in the development mode. So that means if I execute this, the school API again, let me remove this. We don't need it. It was the port issue. I have given the wrong port. Now the port has changed. I need to update it. So if you see this here, hosting environment is development mode. So whatever the cars we are allowing here in this pipeline, we are allowing the cars only if the environment is development mode. If the environment is not the development mode, that means once you deploy that to the app service, it will not be the development mode. It will be the production mode. So at that time, this will not be allowed. So now we have discussed the cars and we discussed the integration. And we also told that the cars is very, very important. So please do not allow asterisks as I did it. That is a very dangerous thing. People might take undue advantage of that. So instead of allow any origin, we should allow origins with. So like we need to do the whitelisting. It's not previously blacklisting is the one which was helping us, but now it should be whitelisting. I'll tell you the difference. So with origins, so you have to whitelist. OK, I'm allowing this UI. I'm allowing this UI. So you whitelist. So in previously, what used to happen is we used to do a blacklisting. That means if some call is coming from a box or an IP which we don't remember, we used to blacklist that IP. And if some attacker is coming from another IP, then we used to block that. So how many IPs we will block? We need to spend our 50% of our life to monitor that. So instead, what the industry has started doing is they started whitelisting. So saying that if the packets or the network, which is from where the requests are coming, if it is between so and so, I'm allowing, or this one particular IP, I will allow it. So by doing whitelisting is like you're safe, isn't it? Whatever the box you want, whatever the IP or the network you want it, you're only allowing the traffic from that. So rest of the calls will automatically get dropped in the load balancer or FI, the appliances, whatever you use it as part of your solution, it definitely gets dropped then and there itself. So it's always good to have this. OK, so the next thing is we'll come to the deployment in Azure. It's very simple. So uh, let's see things. Suppose if you want to create a web app, we will create a web app. I just want to give some information. It's already there, but I just want to show you and give some tips and tricks on this one. So when you select a web app and the environments which it supports, we will see step by step. You can select code and also you can select the operating system, what you want. So container is a different thing, which we can discuss on some other day. Mostly containers, it uses Linux because that's a bit lean and faster. Now, when it comes to code, not all environments will work on both the operating systems. Suppose if I select full framework, you see that Linux is grayed out, only Windows. So full framework works only on Windows. Suppose if I select .NET 7, I can have a flexibility to select either Linux or Windows. So that's one important point you need to understand. So whatever is the runtime which you select, based on that, it might be supported in both the operating systems, or it will be supported only in one operating system. So sometimes if you see that Ruby, the Ruby is only on Linux. It's not being supported in Windows. Maybe this version, I don't know, but if I select Python, it's again only Linux. And if I come to PHP, it's Linux. So if I come to Node.js, so this guy, let's go to the latest version. OK, Node 18. Node 18, it says that, OK, I'm good with either of the operating systems. And similarly, if you see Java, that guy is OK with both operating systems. And if you come to Go, this guy is comfortable in Linux. It's not fully supported in this one. So that's very important. You need to understand when you are deploying it. So please ensure that what is your flavor of the operating system, that depends based on the runtime stack which you select. And the second thing is exploring the plans. So there is a relationship between the web app and the app service plan. So what is this app service plan? So this app service plan is a promise that X computing power will be allocated for our application. OK, so if you see here, free and basic are available, but shared is not available because the Linux operating system will not have that shared one. Suppose if I select Windows operating system and now go and verify the app service plan. Now, if we go and verify the app service plan, it will allow all different, including, I mean, the main difference is the shared one. Apart from shared, everything is same. And also you need to check about the prices. So exploring this plan, if I come back to this one, let's speak about this plan a little bit. When you see this free, basic, and all different things, what is that you're going to understand is they are guaranteeing some computing power. So that means 195 Azure compute units. OK, Azure compute units or vCPU is an approximation of the SKU's relative performance. That means some computing power is being guaranteed. So based on your business requirement, you can get to the pricing tier which you are comfortable. Because if you select this premium V3, that means you're going to pay almost 9,000 rupees per month cost. Okay. So similarly, if you select the Windows operating system, the prices might vary. If we select this Windows operating system, we might see the prices might be definitely varying. So that is one another important point we need to understand. And now let's come back to the app service, web app and app service plan, which I already created. If you see here, this is the app service plan. And inside this app service plan, in the overview page, you'll get almost all the details. Like it says that operating system is Windows and the pricing plan is D1. So if you come to scale up, so you can bump the pricing tier to more. And as I was mentioning, if you see the premium tiers, you're not getting it for 8,000. You're paying 5-digit number. But when the operating system was Linux, we saw that it was coming around 9,000, 8,800 or something. But here for the basic, you're paying the same cost what you are getting in Linux. So you can also check the pricing between different operating system and which one you want to choose. And in the file system, you will see what is the hard disk space and how much has been used. And apps is the one which will be shared. Here, if you're sharing multiple apps, you will see this here. And before, you need to look at, we saw that from the hardware view perspective, we also need to look at from the features view perspective. So that means you will get whether you're getting an auto scale, whether it is manual, whether it is not applicable or rules and elastic. And are they going to take the backups? How many backups per day? And do you need a staging slot and how many staging slots they are allowing? So also you need to keep a watch on the features. What features do you want? Okay. So if you want a custom domain at basic, you need B1 plan and they allow manual auto scaling, but only 3 instances. But you need to go deep into the weeds to find out what is that they're going to allow. Now coming back to this one over here, we see this is the app. Okay, the web app. And on the left navigation, if you come to the cars, okay, so here in the cars, we have allowed HTTP localhost 4007. So that is the reason we are able to talk to this one. So if I come back to the web API, sorry, the client Angular UI, I come back to this one, I'm happily going and getting the content. Suppose if I switch that to this one, okay? Now if I switched it, now we come back and I'll go to the home page and come in. Oh, it's caching this. It's caching the call. So now that we asked it to go get it, so you can see that it clearly says that CORS error. So it's not allowing CORS because we didn't enable the cards there. So we have to do the whitelisting, because if we put asterisks over here, this is what we discussed when we were allowing in the dev environment. If I put asterisks over here, I will be able to hit it from any application. It will not stop me. It will not stop me from see that I'm getting the content, whether it is 4007, 8 or whatever the IP it will allow. It's like a wildcard blank check. So never ever do this. Always we have to whitelist. That means allow one by one. So you know that which endpoints you are allowing. So this is a wildcard. Anyone can come and happily steal whatever they want or utilize your API or services to the core, because the every app service plan is backed up by the computing power, and they're saying that this is what you're going to get. If a lot of people they come and hit your API and assume that you're hitting a third party API to bring some of the information, and third party API will charge you based on number of calls you hit him. So your billing might bump it up for whatever the reason, just for the security sake. Always use the whitelisting mode. In good olden days, the blacklisting used to work. Nowadays, whitelisting. So I'm allowing A, B, C. That's it. Only 3 people. I don't care about rest of the world. So previously we used to say that I will not allow D, I will not allow E, I will not allow F. So these 3 people. And if H comes, oh, I should not allow him, add him. So previously the blacklisting was working, but nowadays blacklisting will not work. We need to do a whitelisting. That means we have to choose step by step whom we want to allow, and um, we need to allow them. Okay, so that's it from my side. Hope you guys have learned something new. And oh, you're on mute.
Yeah, hi Swami, hi everyone, and thanks for joining the session. I can see one question actually, Swami. Maybe you want to answer.
Normal
Jubin
ones.
was one question. What
Mm.
plan you suggest normally one should choose for production? I believe it is during when you are showing different plans.
Yeah, yeah. So
Yeah.
the plan, whatever you have to choose will be based on the your production load, because um, what you should do a baselining testing before you go to production. So what is baselining is, suppose if you create an API and you deploy that API to a small, like basic or standard uh, plan, and do a performance testing. And what will be the number of concurrent users that we will get it from the uh, business analyst or the product team will tell that what is the concurrent number of users per second. So based on that, we do a baselining testing, and then we will understand what should be the plan. Like suppose if the number of concurrent users per second is 100, and standard plan itself is supporting 200 users. So we can go with the standard, and then we need to write the rules to horizontally scale. So vertical scaling, you can do it, but even though you take a high-end car and you're driving very slow, so it's the same thing. So similarly, you take a smaller uh, computing power, scale it horizontally. So that means if 100 users per second, it's going well. and all of a sudden, one fine day, you're getting 400 users per second. So based on our rules, it will horizontally scale, auto scale, or scale out. So it will add more number of instances so that the request will not get dropped. So this is the safest approach. So, and also we have to plan this. This is the capacity planning. We will do it before putting it to the production. But this will not guarantee us that we are safe in production. So that is the reason what we used to do is we used to go one load more than what is the business demand. That means if the business says that they will be having 100 user concurrent users per second, so we will split that into 5 categories. So extra small, small, medium, large, extra large. So the large is the one which is 100 users per second, and medium is 75 users per second. Small is 50 users per second. Extra small is 25 users per second. And extra large is whatever the business says that 100 concurrent users, that plus 25%. That means 125 users, concurrent users per second. So we will do the performance endurance testing of all these 5 loads. That means any day, even if there is a spike, our application will sustain. It will not come down. And on top of that, we need to write the rules to add more number of instances based on the metrics or the capacity, whatever this it is showing the memory or CPU.
Yeah.
Yeah, hi. This is Jubin.
Yeah.
Yeah. Thank you for your answer. Just do you have an example? Can you send me like where do you see the metrics and how do you auto scale it?
Oh yeah,
Maybe,
sure.
yeah. Maybe just
We'll.
share it in the chat so I can just look at it.
I'll show you right away. So in the same screen, we went in the scale up. This is vertical scaling. So the horizontal scaling is the one which will allow allow you to do this one. So because mine is the basic plan, if you see auto scale Azure web apps. So if you come into this one, so you have these settings here. So you can write these rules like based on metrics or scale to a specific instances. So the metrics, you can choose what should be the metrics. Okay,
Okay, okay, thank
yes.
you. Got it.
I
Yes.
will send this one.
Because normally in my projects I use like bicep templates to deploy these APIs, and then
Okay.
I defined all these things over there. So okay, cool. I got it. Thank you.
Yeah, you can get it from here. Cool.
Okay. I think it's really a great session, and thanks, Swami, for the joining the session. It's a very short notice, I understand, and
No problem.
I really appreciate your contribution to the community. That's for sure. And thanks everyone for joining and retaining. For I think we are still 4 minutes ahead from the actual time. Actually, 8 by 8 we have to complete in Singapore time. I'm saying but we are in 8.4. So hopefully this session is helpful, and mostly we do in Power Platform. But why we selected this topic, topic? Normally, if you notice, Power Platform and Dynamics, along with Azure, always it go hand in hand. You cannot skip, let's say, anything you required. You required web app, you required Azure Logic app, you required some Azure functions or something to integrate and all these things. So that's why it is always integral part for the developers. But yeah, this session is a really great session for the developer point of view, whoever doing the development. So if any business users, I understand it will be something informative for them. Good to know, I will say in this way. But yeah, it's really helpful session for everyone, whoever joined. And thanks everyone for joining. I think I finished it 5 minutes. Thanks, Swami, for joining.
Thanks,
Thank you
guys.
so much. Thanks
Bye.
everyone. Thanks. Bye.
Thank you for the session.